Welcome to the lesson on similarity and enlargement. We're going to begin with similar triangles. Learning objective of the lesson. By the end of the lesson, you should be able to explain how the scale factor applies to similar triangles. Learning outcomes, you should be able to understand how the scale factor applies to similar triangles, and also you should be able to solve problem using the scale factor. So let's begin with the conditions for similarity. When two shapes are similar, then there are two conditions that the two shapes are supposed to satisfy. Number one, the corresponding sides are supposed to be in proportion, and the corresponding angles are supposed to be equal. Now look at these rectangles that are here. All rectangles are not similar. The reason, because only condition 2 is true, that the corresponding angles are equal. When you look at these angles, they are 90, 90, 90. So all the corresponding angles are equal, and they are 90. So these are 90 corresponds to this side, which is 90, and so on. So 2 is not the condition 1 is not met. So if two shapes are similar, then one is an enlargement of the other. As you're going to see in this example here, that the rectangles below are similar. The reason why they are similar is because they have met the two conditions that we have established in this part. One, the corresponding sides are in proportion. So let us test whether the corresponding sides are proportional. So to establish that, we just need to take one side, this side, which is 16, we divide by the corresponding side on this rectangle, which is 8. So 16 divided by 8 is giving us 2. That one should be equal to, if we pick another side, which is this side, which is 10, and then divide by the corresponding side, which is 5, is going to give us 10 divided by 5. So you realize the same. So 16 divided by 8 is equals to 10 divided by 5, which is going to give us 2. So that one is tested. Corresponding sides are proportional. Then the other one is the corresponding angles are equal. You can see all of them are 90. This angle corresponds to this 90. This one corresponds to this 90, and so on. So the scale factor of enlargement can be given by, take this 16, divide by the corresponding side, which is 8. So enlargement scale factor is 2. Or you can take the reduction scale factor, whereby you are going to use this 8 divided by 16, which is going to give us a half. That is reduction scale factor. Enlargement scale factor, 16 divided by 2. You can also use this one, 10 divided by 5 and 5 divided by 2. So both of them are the same, they can be used, only that one is a enlargement scale factor and the other one is a reduction scale factor. You can also try to do it using this example again. These two are similar because the two conditions are satisfied. When you take this side, 12 divided by 8, it is equal to 7.5 divided by 5. It's going to give you the same figure. So all those conditions are satisfied. The two conditions are satisfied here. If you want to get the scale factor of enlargement, you just need to pick either 12 divided by 8 or reduction scale factor 8 divided by 2, and you can use any side as long as the sides that you're using are corresponding. Like this 12 corresponds to this side. Now if we are told that two objects are similar and we can find the scale factor of enlargement, then we can calculate the value of a known side. I repeat that. If we are told that two objects are similar and we can find the scale factor of enlargement, then we can calculate the value of the unknown side. So what we mean by that statement is that we can use the scale factor of enlargement to calculate the unknown side, to get the value of the unknown side. Like this one, okay, this is rectangle A, rectangle B, rectangle C. So let us consider rectangle A and rectangle B and get this unknown side, which is x. So look at this side. Look at the corresponding side. So take the corresponding sides and divide them. Like this, 24 divided by 8. That one is giving us enlargement scale factor. It is telling us how much has this one been enlarged to give us this. So you realize it's 3. Therefore, if you want to get this x, you just need to take that one has, this is a side, x corresponds to this side, so this x corresponds to this side. So if the enlargement scale factor is 3, then it means that you just, to get this value, you just need to multiply this 3 times 3. This 3 is the enlargement factor to get 9, which is this side. You can also consider rectangle A and C, whereby you're going to calculate this unknown side, which is y. So take the corresponding side, the ratio of the corresponding side, and the ratio here we're going to give us take 13.5 divide by the corresponding side, which is 3 here. So look at how we take the corresponding side. This side corresponds to this side, so 13.5 divided by 3, that one is giving us 4.5. So it means that this one has been enlarged by 4.5 times to give us this. So for us to get this y, we just need to pick this y corresponds to this side. So this 8 corresponds to this side, which is y. So we just need to take 8, we multiply by the enlargement scale factor, which is 4.5, and we get which is at 6. Now you can also try it to this example again. They are not drawn to scale. You consider A again and B. You can get the unknown side. This is x. You can get this side. You can also consider A and C and get the unknown side, which is y. So the same way, take A and B. So get the ratio of the corresponding side. So this side 7.14 corresponds to 2.1. So you divide 7.14 divided by 2.1. It's going to give you enlargement scale factor of 3.4. So therefore this x is going to give us, pick this x corresponds to this, 5.6 corresponds to x, so 5.6 multiplied by the enlargement scale factor, which is 3.4, is going to give you this. So you can also do it the same way for A and C. Now let's go to similar triangles. Now similar triangles are very important in mathematics, and their application can be used to solve a wide variety of problems. Now the two conditions for similarity between shapes, as we have seen earlier, are 1, corresponding sides are supposed to be in proportion, and corresponding angles are supposed to be equal. Now triangles are exception to this rule, because for triangles we don't need to use the 2. You can also use only when the second condition is needed. Only the second condition is needed for us to prove the two triangles are similar. So if we just establish that corresponding angles are equal, then we can conclude that the two triangles are similar. Like these ones, these are similar triangles. Now look at these. These examples of similar triangles, and the triangles are said to be equiangular. These they are similar because you can see the angles, the corresponding angles are equal. So this 70 corresponds to this, 45 corresponds to this, and so on. These are 50 corresponds to this, 55 corresponds to this angle. When you calculate, you get the same thing. So we shall go to the scale factor in our next lesson. So